Up until this point, whenever we have manipulated data within our database, we've just sent individual commands into the database and then displayed the results. When you're using databases in the real world though, it's much more common for issues to arise if you do things like this, drawn from the fact that there are often many concurrent users, and in the time that it takes for the first command to execute and the second command to execute, another user could easily have jumped into the queue and performed another command, which would change your data and therefore change the results that you see. If you think about ordering something from an online store, for example, you need to provide information like your name, your address, your bank details, delivery details, as well as details of the thing that you're actually going to buy. And all of this information needs to be stored in the database, often across multiple tables. What would happen if halfway through processing your order, the online store's database crashed, or another order was being processed at the same time? They would be left with half the details of your order and half the details missing. Or even worse, half the details of your order and half of the details of someone else's order. They obviously wouldn't be able to process those orders properly, and you would probably just go to a different website to buy whatever it was that you were buying in the first place. This is where transactions come into play. When you're performing a whole group of actions like we've described here, you should minimize the risks of being left with only partial entries in your database. Otherwise someone is going to need to manually edit your database to remove partially edited data. So transactions are a way to group a whole bunch of commands together, but none of the commands are actually saved into the database until all of them can be saved together. This means that if you tried to insert some data into your tables, but the database crashed before the last command in the transaction was processed, none of that data would actually be saved into the database, and then you therefore don't need to go into the database and manually figure out which records to delete. The commands to use transactions are very simple. Start transaction indicates that you're going to start a transaction. You would then ordinarily turn auto commit off. Auto commit is the parameter which tells MySQL to save after every insert, update or delete. And because we want to do all of these actions at once, we don't want MySQL to be saving each individual action. We want to send a single commit at the very end, which will save all of the actions for us at once. So next up you would normally have the code that you wanted to actually perform. So you could insert some data, you could update, or you could delete. As you're progressing through your query, you would then have a save point. And this is just a point which your query can save at. It doesn't necessarily have to save at this point, but you can save at this point, or you can use it to revert back to later. You may then have some other commands, so you may insert more data, you may delete more data, you may have different where statements within selects, and then depending on the output you could have a second save point. Later on you could then roll back to, for example, the first save point, and this will remove all of the actions performed between the first save point and this actual rollback command. You could also just roll back to the second save point, in which case any commands here would just be deleted. And because we're not saving the data as we progress actually into the database, it's easy enough to do this without impacting our entire database. Before the end of the query, you then normally have some sort of validation. And this is where things like checking that data has been inserted properly into your database would be done. So you would typically do multiple selects here, selecting the staff and then searching at the same time. For example, if you were to insert a new staff number, you could then check that this actually does return a value, that those values are correct according to what you've inserted up at the top. And then if not, you can use the rollback command to go back, or you can then, if all of the data is correct, you can use the commit command, and this will save the database in its new state. If you don't commit, then all of the data up until this point would just be lost. It's the equivalent of opening maybe a Microsoft Word file, typing something into it, and then closing without saving. The commit command actually saves the data into the database for you. Now, because we've changed the environmental variable here, auto commit, it's also good practice to revert this back to its original state. And this is to ensure that all of the future queries which are performed within this session are actually going to commit properly. You don't need to type commit after each statement, which would otherwise be the case. It's always good practice whenever you're doing any sort of programming, whether in SQL or anything else, to always revert back to the original state after you've changed an environmental variable. And this is just to help everyone else who's working on the project, or even yourself if you forget about the fact that you've changed the environmental variable, so that everyone knows exactly where the database will be at the start of their query. It's always going to be in the same state. It's also common when you're using transactions that you will require, or that you'll at least want, to restrict other users from changing the data within the database while you're using your transaction. And you can actually lock the tables within your database so that other users can only read or write or perform any specific actions that you want. If you do lock the tables, however, remember that you should always unlock the tables again, which is just performed by unlock tables. And this again goes back to the fact that you should always leave the environment in the state that you found it. And because in this case the staff table was unlocked when we found it, we could both read and write to the staff table, we should always revert it back to that state before we exit our transaction. Now, the lock tables command itself can be extremely powerful, especially if you're using lots of different tables all at once, but you want to ensure that the data doesn't change across any of those tables for the duration of your transaction. Locking tables does also have one major drawback, which is the fact that it does restrict other users from performing actions. This may not seem like a big issue if your database is relatively small, but if you have many concurrent users who are all trying to access the data at once, this can cause significant problems. And so you should never really lock tables which are being used in a production environment. If you did genuinely need to lock tables, it would make more sense to actually copy the entire database onto a separate server so that you can manipulate the data separately without being worried about other users trying to change the data. And this is because especially in things like website development. Locking tables means that your users cannot use your database, which means that your users cannot use your website, which is obviously going to have negative consequences in terms of their user experience. Just before we move on, I just want to highlight the fact that there are some different options that you have available to you if you do want to lock your data. You can select things like low priority, write, and if you set this restriction on your table, this will allow people to write to your table still, but the data that they write will be very low priority. So that means that your database won't go ahead and just write immediately to the database. It will store the changes in memory until it has an opportunity to actually go ahead and write it into the main database. But this too has some negative impacts, because the way this works is that it will save any changes in the computer's memory rather than writing it to the hard drive. So if your computer crashed or there was a fault in the memory, that data would then be lost. So just remember that there are different types of locks that you can apply to databases and tables specifically, but you shouldn't really be using many of them in production environments. You should typically use them in non-production environments, so as I say, mirrors of the live database, things like that.